Hi, I'm Luis Gabriel, and this is explanation about the experiment number 2. Let me share the screen. As you can see in the simulator, I recreated the circuit number 2. Here is the 6-volt battery, the resistor number 1 with a value of 10 ohms, and the resistor number 2 with a value of 66 ohms. First, what I had to do to calculate the current is to use this ammeter to connect it with the battery and some of the wires, and here I get the value of the current. As you can see, from this side of the circuit, the current is constant, but it isn't slow. But in this side of the of the circuit, the current is very slow. And to calculate the voltage, I use this voltmeter, and I insert one part here and the another part here. Then I get the value of the voltage. Now let's get to the calculus. Here, as you can see, to find out the equivalent resistance, I use the formula for the equivalent resistance that divides the resistance 1 and 2 over 1 and change it so all of this is over 1 and change it so it is at -1 exponent. Then I I added the 10 ohms and the 66 ohms, and I got 19 over 165. And all of that is up to the exponent -1. Then I swapped the values and I divided the 165 over 99 over 19, and I got 8.68 ohms. And for the current supplied by the battery, I used the typical formula to get the current by dividing the voltage over the resistance. So I divided the 6 volts over the 8.68 ohms, and there I got 0.69 amperes. And that's the same value that we got on the simulator. And for the current of both resistors, I used the same formula, dividing 6 volts over 10 ohms and 6 volts over 66 ohms. And that's how we got for the first current 0.6 amperes, and for the second one 0.09 amperes. That's the end of the explanation. Thank you.